Up to 80% of broccoli biomass is left to waste on farmers' fields.
So when you go to the supermarket, the broccoli you buy is maybe 4 or 6 inches high, but the plant's much bigger, leaving this biomass on the field that we can process into high quality, nutritious, highly protein and hypoallergenic ingredients that you can put into burgers, sausages, cakes, sauces or soups. So the problem with broccoli is that it's very, very labour intensive to harvest. We're going to solve that problem by automating the harvest, and that means that less of it will get left on the field to rot and more of it will arrive on the supermarket shelf. And it's got low food miles because it's made up here in Scotland. So this is very much a coalition between the UK Agri-Tech Centre, the James Hutton Institute and UPP.
The funding for this project is primarily from Innovate UK and DEFRA.
Well, at the front of the machine you've got an AI camera that senses a ready broccoli, and it measures the size, which is important to picking broccoli because all the broccoli that goes to the supermarket is based off of weight. The weight's equivalent to the size. That sends a signal to the machine at the back, which is the white conveyor going round, and the timing gets it just like that, grabs it, cuts it off the floor, sends it up the back to the conveyor and drops it in a potato box, ready to be sent back to the pack house. So the funding that SusProt has provided has allowed us to research and develop a leaf stripping mechanism which is fundamental to our machine.
The UK Agri-Tech Centre is providing the project management, the facilities and the support for UPP.
What this project is focused on is the onward processing. It's stripping away the leaves and then it's looking at how to take these stems and then better produce a workflow that will take them to being usable inside our protein production process. So the SusProt project has funded us currently to a pilot plant, and where this is going is to take the plants that we make and put them into ISO containers, 40-foot long containers that can be deployed on farms to further reduce the food miles and the energy required to move things around.
So the broccoli stem will go in essentially at one end, and coming out the other side will be the 3 ingredients: the pulp, the liquid and the fibre. So the broccoli comes in off the field, it's washed, so it gets submerged, then it goes through our wash tunnel. From that it gets put through a mill to break it down to give us a consistent size of fibre. At that point we juice it, the juice gets separated into our protein and our liquid fractions and the fibre fraction. We are looking at producing 3 fractions. Here we've been working alongside with the team and the chefs here to produce a hybridised burger. So that will be 80% beef and 20% of our protein fraction. With that we're going to be producing bread rolls to serve them on, which we're using our fibre fraction as well as a standard white bread recipe. And then additionally with that we're producing a broccoli based loaf of bread using our ingredients. I like the versatility of the protein. I find that the fact that we can use it across the board, from everything from smoothies to a burger, to a hybridised burger, to a kofta. We've got a protein that uses soups and smoothies, stews and hybridising burgers. We've got a fibre fraction which uses in bread, we're using sausages, and also works in like biscuits and confectionery. And then we've got a juice which you can grow mycelium in. It's around 3% sugar. We believe that people really, really like this, with all the sharpness and the depth and nuttiness that you'd associate with a sourdough. Tastes great, tastes just like a standard 100% beef burger. You can't taste the broccoli and it still delivers the flavour.
But it's 20% broccoli, which means it's far lower CO2, slightly lower cost, but also includes a whole load of good nutritious properties in there. So what we're doing at the moment is we've got the pilot line producing the different products we're making, which are currently going for test, not only at JHI, the James Hutton Institute, but also at commercial labs.
The Hutton's role in this project is to actually confirm that the products made have the nutritional and health beneficial effects that we believe they actually have, so especially protein. The amino acid composition of that protein, trying to match it to readily used alternatives such as soy and pea protein. But we're also interested in the sugar levels and things called phenolics. And phenolics are really important in broccoli because they have antioxidant effects which are believed to have various health benefits.
You need the core amino acids that the body requires to grow and be strong and to function. And to date, we have seen that our amino acid profile is comparable to that of soy and pea.
These broccoli products not only do have high levels of proteins, they've got good levels of dietary fibre and also the antioxidant components, but also they're very easily integrable into various food products. And that can be as a high protein component on their own or as an additive to a plus meat type product. We've done a full life cycle analysis which proves we have a planet positive impact in line with 2030 commitments.
We're able to look at each byproduct and main product, identify the energy and therefore the cost associated with that product, and then allow them to look at the energy intensive hotspots and high emissions area of that process to develop and improve the process into a second generation.
So what's next is looking at valorising other side streams. So we have had some early success on cauliflowers. We're also looking at utilising hemp stalk, carrot tops, stems from parsley and coriander and whatever else is out there.
For more information on this project and others, get in touch today.